Welcome CHEM152L to the last pre-lab lecture. We have made it. Nice job. This is experiment 12. So your pre-lab data, post-lab, that's due. That's the last week of the semester. And if you have questions over this, come see me. We can meet in Zoom and go over any of these last questions. You can also contact your lab assistant. So you can do that on Canvas discussion board. You can email them directly, but Jamie and Kara are available. They did a great job last week doing the pre-lab lecture, contributing. So really encourage you, engage, ask questions. We're all available to work with you. The last week of the semester will be exam 2 and the lab practical. So that's experiments 7 through 12. Please note this is just like exam 1, okay? So that means those experiments, think about the definitions, concepts, equations. So look through experiments 7 through 12. Do I still recall what the focus was? You can even look back over at exam 1, what kind of questions were asked. There is a, this is a big quote here, right? Hands-on component. So it will be this kind of measurement skill, again, that you accumulated where you're on campus and what we've simulated off campus. You'll have been emailed lab assistant evaluations. So this is feedback for your lab assistant. What did they do that was helpful? Do you have suggestions for improvement? Thank you for all that you did for us. You can say lots of things in there. So I really encourage you, please take the time to give some feedback. We all would appreciate that. So there's a quiz associated with this experiment. So that's your last quiz. And this is the end. So I usually like to just take a few minutes to reflect on what we've experienced. And of course, this is clearly different than any other semester I've been a part of. I'm sure maybe the same is for you. But I think about our classes, and it's been a significant adjustment. Once a week on campus in a lab, I really thought we were just getting into a groove of, where's the equipment at? How do we do this? Turn in the pre-lab, turn in the post-lab, getting your hands on things. So really getting in a groove. So I'm for sure sad that you didn't get to continue on campus, but I hope that you've taken away from these simulations, these videos, still some chemistry skills, some interest that you'll take with you. This last experiment is one of my favorite. It's titrations, and I'll talk a little bit of why it's important and why you'll continue to use this. So we'll look at the reaction indicator, equivalence point for the calculations. So we'll talk about that here. But this is the schedule. So experiment 12, and then it's the exam after that. So a couple of things to note. I really encourage you, watch the video and make observations on this video. You are not doing a titration, okay? That's very sad. That's the reality. What can you do? Well, you can learn from other people doing a titration, because if you continue in chemistry, especially at Miramar, our curriculum, there are a lot of titrations. So Chem 200L, Chem 201L. So not only do you do them, but they're also a vital part of the grades in both of those classes. So learning the technique, observing the technique, that's a really key focus here on experiment 12. I know it's the last one, it's the end, but put in the time to see. You're going to see conditioning. So it's really important that you condition or clean the burette and pipette. And condition it is you put in the substance that's going to be in that piece of glassware, and you rinse it back and forth. You cover all the surfaces of where that solution is going to be, and then you dump it out. So that way when you add your actual solution to do the titration, it's not being diluted with water. It's not being contaminated with something else that was left in there. So that is your stuff in there. I know this might sound ridiculous, but you have to add indicator. Many times I see people, I've actually probably done this myself, I'm doing a titration and then realize there's no color change. What's going on here? It seems like it's going on for a really long time. These things are colorless. So if you do not add an indicator, you will be there all day, okay? It's amazing that when you do this, you can open up the burette, and let me just do a crude, you've got your burette on the stand, here, and you've got your Erlenmeyer flasks here, and this is your acid and your indicator. So your burette, you can open up, and this will go in, and ta-da, a color change will happen. Okay, there's nothing magical about that. It will happen. What we want, though, is one drop to make the color change happen. Okay, so what I mean by that is you may start out here adding this in large increments and you not notice any color. Okay, so I'm trying to draw increments here of liquid, and then you notice this large increment here, you start to see some pink develop. So now you want to add very small increments. I can't even draw it, it's so small. You want to, at the end, you want to add it dropwise, so one drop turns the whole thing pink. And at times you'll have classes do a little competition, who has the lightest pink. And it's very difficult to try and get to that point, but if you don't, you over titrate and then your calculations are all off. So dropwise is the key. So here's some skills. You need to read your eye level. So if you're reading the top here, you want your eye level to be with the meniscus. The markings are to the tenths place, so you need to read and estimate to the hundredths place. You can have air bubbles in the burette here or under the tip here. If you have air bubbles, clearly that throws off your volume, so you have to shake them out, run the solution through again. At times, if you've drained it empty, then this tip can be empty. Well, that has to be full for the volume to be accurate, so you want to make sure that the tip is full. And then many times people waste their time trying to get to the start of, is it 0.01 or is it 0.03? You don't have to start at 0.00. You can start at 1.23. You can start anywhere, because what you're measuring is the change. Okay, so if you start at 1.23 and you go to 24.56 milliliters, then you subtract this to get to the change in volume, and that's what you use for the calculation. So I've put here the chemical reaction. This is acetic acid, sodium hydroxide neutralization reaction. So right away we should be thinking that's a water and a salt. So that's water, and that's liquid water, and that's sodium acetate. And of course, if you have a chemical reaction, do not be fooled. Balance it right away. So I'm leaving blanks here. In this case, it's not a huge concern, but some of you saw in solution stoichiometry, if you just assume it's a 1-to-1 ratio, then you'll be off on your calculations many times. So start, double check, is it balanced? And this is old chemistry. You can go through and do the complete ionic equation. This forms H+, this forms acetate, and write out all the complete ionic equation. And we actually did this in the experiment. The net ionic equation comes out to be the H plus OH minus gives us our water. So that's our net ionic equation. So you could actually write the calculations based on H plus and OH minus. In this case, I wrote the calculations based on the full formula of the acid. So that's HC2H3O2. So that's the net ionic equation. So the equivalence point then is where the moles of acid or the moles of the acetic acid equal the moles of the base or the moles of the sodium hydroxide. So as we said, this is the point that we want to look at, the equivalence point. Well, they're colorless, so what we actually get to is the color change, and the video does a good job of showing you the difference between an endpoint and an equivalence point, but many times people use these interchangeable. They're not the same, but if you choose the right indicator, they're basically the same. So what you're going to see then is you're given a stock molarity, which we should break out right away, moles over liter. So you fill out what's the concentration, and then you're going to titrate. This is in the burette, so you're going to titrate how many liters of sodium hydroxide did you titrate. Remember the balanced chemical equation, you want to double check that here, and put in the mole-to-mole ratio. And I put a 1 up here. You can write this in many different ways, but I did this in dimensional analysis to show if you've got the moles of acid, then you divide by the liters of acid, that gets you your molarity of acid. So this is titration. Again, I did many of these in undergrad, but then also in graduate school. Most of my graduate work was on titration, so find this really interesting. It applies to lots of areas, so I encourage you finish strong on this last experiment 12. And if you got any questions, please see me or contact your lab assistants.